Bismillahirrahmanirrahim. Assalamu alaikum students. Welcome to your chemistry class. Our first chapter of chemistry first year is stoichiometry. In this chapter we will discuss some basic definitions and the numericals related to those definitions. Now what is stoichiometry? It is a combination of two Greek words. Stoichio means element and metron means measurement. So it involves the quantitative relationship between the reactants and the products. Here is a stoichiometry map which relates the mass to the moles and volume, particles, and we will discuss these things one by one in solving the numericals. Our first basic definition is mole. What is mole? The atomic mass, formula mass and molecular mass of a substance expressed in grams is called mole. For example, 1 mole of oxygen is 16 grams, 1 mole of carbon dioxide is 44 grams and 1 mole of water is 18 grams. Then we have the next topic, Avogadro's number. It is the number of atoms, molecules or ions present in 1 mole of a substance. Its numerical value is 6.022 into 10 raised to power 23. Next is the conversion factor. We need this conversion factor for solving the stoichiometric calculations or numericals. Based on stoichiometry, we construct the mole ratio, and mole ratio is same as conversion factor. The basic tool for calculation is the balanced chemical equation. In the balanced chemical equation, the coefficients which are present along the reactants and the products, these represent the moles, and the ratio among them is the mole ratio. So the conversion factor is one of the easiest way to do stoichiometric calculations, and a conversion factor is a ratio which represents the relationship between two different units. We will construct conversion factor in solving the certain numericals. Look at the sample problem number 1.1. Methanol burns according to the following equation. 2 moles of methanol react with 3 moles of oxygen to give 2 moles of carbon dioxide and 4 moles of water. We have been given with 3.50 moles of methanol, and we are supposed to calculate in part A the moles of oxygen and in part B the moles of water. Now let us see how we can solve it. Now we can first of all convert the conversion factor between the required quantity and the desired quantity. Now conversion factor is equal to the mole ratio. Moles of methanol 3.50, moles of oxygen we have to find out. Conversion factor, according to the equation, there are 3 moles of oxygen and 2 moles of methanol. As we have to find out the moles of oxygen, so they have to be on the numerator side. And you multiply this conversion factor with a given quantity, which is 3.50 moles of methanol. So upon solving, it comes out to be 5.25 moles of oxygen. And in the second part, we have the given quantity 3.50 moles, same as in part A. And now the desired quantity is moles of water. So you have to construct the conversion factor between moles of water and moles of methanol. According to equation, there are 4 moles of methanol, 4 moles of water and 2 moles of methanol, which will be multiplied by 3.50 moles of methanol. So upon solving, we get 7.50 moles of water. Now based on this sample problem, you can solve this self-check exercise question number 1.1. Ammonia is an important raw material in the manufacturing of fertilizer. It is obtained by the combination of nitrogen and hydrogen. 1 mole of nitrogen reacts with 3 moles of ammonia to give us 3 moles of hydrogen to give us 2 moles of ammonia. Given is 5 moles of ammonia, and you have to calculate the moles of nitrogen and moles of hydrogen. As we have done the sample problem, you have to construct the mole ratio. You will multiply it with the given quantity to get the desired or required quantity. Then we have another sample problem. In this sample problem 1.2, iron can be produced from iron ore. Iron ore has the formula Fe2O3. It reacts with 3 moles of carbon dioxide and it gives us 2 moles of iron and 3 moles of CO2. We have to calculate the mass of iron that can be formed from 425 gram of iron ore. Now we have been given with 425 grams of iron. We have a very basic formula that number of moles is equal to mass in gram over molar mass. So mass in gram is 425 and molar mass of iron ore is 159.6. We get 2.66 moles of Fe2O3. Why we have converted mass in gram into moles? Because calculations with moles are easier and simpler. Now the moles of iron produced. The given quantity multiplied by conversion factor would give you the desired quantity. So you have been given with moles of iron ore 2.66 and the moles of iron according to equation are 2 moles and iron ore is 1 mole. So upon calculating it comes out to be 5.32 moles of iron. If you just look at the question, you have been asked what mass of iron is produced. So we know that number of moles is equal to mass over molar mass. Mass in gram is equal to number of moles multiplied by molar mass. So number of moles are 5.32 and molar mass is 55.9. So upon solving it comes out to be 297.388 grams. Now refer to self-check exercise 1.2. The main engines of the US space shuttle are powered by liquid hydrogen and liquid oxygen. If 1.02 into 10 raised to power 5 kilogram of liquid hydrogen is carried on a particular launch, what mass of liquid oxygen is necessary for all the hydrogen to burn? Now you have been given with 1.02 into 10 raised to power 5 kilogram of liquid hydrogen. First of all, you can convert this mass in gram of liquid hydrogen, mass in kilogram of liquid hydrogen into mass in gram, and then by dividing with the molar mass you can calculate the moles of hydrogen and you can relate it with the moles of oxygen. So the moles of oxygen which are formed, which can be solved at the end, can be converted again into mass in gram of oxygen. So based on the previous sample problems, you can solve it accordingly. If there is any confusion, you can ask me. I hope you have understood. Thank you.